Yeah, I think there is no doubts or no clarification needed for the yesterday's session, and we will be jumping into the session today directly. Yeah. Today, majorly we are looking into the how the PCB design flows and what all the phases will be having in the PCB development phase. Yesterday, we have seen what is the requirement of PCB or what is meant by embedded systems and how the classifications are there in the embedded systems. And when we will convert the design into the PCB and what all the basic steps that need to be followed in the PCB design flow, such kind of things we have seen. We will see in today regarding like hardware design workflow versus PCB design workflow. Even in the same hardware session, there will be two kind of different teams. What are their job roles and what they will do? We'll be discussing them in detail, and we will be seeing PCB design workflow in detail and understanding the schematic designs versus PCB layout designs and exploring of PCB design softwares like EasyEDA, KiCad, Altium, and we will see what are the other softwares and its use cases. And there is a small scope of installation of EasyEDA software. We will looking into that, as well as we will demonstrate and we will show you how to create a PCB from a scratch to an end level in very hyper level. In further going ahead days, we will be demonstrating in my PC. You can follow that and you can do the same in your PC. And we will be discussing regarding the types of PCB layers, so what is meant by single layer, double layer, and multi-layer, and how they are having a different kinds of advantages with using the same form factor. And we will be seeing few industry standards for the PCB manufacturing and AI integration capabilities for the easy EDA software. Mainly, we are focusing on easy EDA software. I will explain why we are using easy EDA further going. Okay. Mainly now, the hardware design workflow versus PCB design workflow. Even though we will consider both of them as a hardware team, here there will be a two kind of classifications or two kind of workflows in the real-time industry. One is hardware designer, another one is a PCB designer. Where hardware designer part or the role will comes until the proof of concept of the circuit designing. Like they will gather the requirements, they will analyze the architecture, they will do the module level implementation, they will design the circuit or the schematic, and they will do the proof of concept. Even after the PCB comes, they will also be the include in the phase of testing. But the PCB designers will be in the phase of requirements gathering, component selection and footprints, schematic designing, layout designing, the DRC check, design rule checks, as well as Gerber and bomb file generation, PCB fabrication and its assembly, and final PCB. They will be in this stream flow, and hardware team will be in this stream flow. In many of the companies, both of them will be come under a single person. In few companies, based on their cap size of the teams as well as the capacity of the project, there will be having individual persons too. And coming to the PCB design workflow, as we discussed, there will be requirements gathering, component selection, schematic design, layout design, DRC check, Gerber, as well as PCB fabrication. What is meant by the schematic design? The schematic design is nothing but a logical representation of the circuit which uses symbol to represent and components like resistors, capacitors, ICs. The each and every annotation we will consider or call them as in symbols with respect to the schematic analogy, and which shows the electrical connectivity but not the defined physical path or the placement which is in the actual PCB. It only shows the actual connectivity, how it need to be connected electrically, and created by using a softwares like KiCad, Altium, EasyEDA, ARCAD. Anything can be worked out, but one thing that need to be noted, like whenever we are designing the schematic, the same software should be used for the PCB design also or the layout design also. We cannot use schematic in one form and layout in another form. If we want to use it such a way, we have to migrate the schematic from one software to another software. For an example use case, let us say if I had a design and schematic in Altium, if we want to design a layout in the EasyEDA, we have to migrate the Altium software into EasyEDA, and then we have to do the corresponding layout work. We'll be seeing what is meant by layout now. PCB layout is nothing but the placement and each and everything. You can see it in the left side of the image. It is like a physical design of the PCB, defines the actual component placements and converts the schematic into real world PCB with traces and viases. Viases is nothing but a connection from plane to plane. Traces is kind of in wires from point to point, which gives an electrical connectivity from point to point and ensures components are automatically positioned to reduce the noise and interference, and considers mechanical constraints such as board size, mounting holes, and fixing accessories related to the mechanical point of view. And if we see the PCB design softwares, like basically in the market, very prominently used softwares like Easy EDA, which is completely a cloud based. No need to install it in a software in your PC. Directly you can open it in any web browser and you can use on the go. It is for the beginners or hobbyists or and for online collaboration. It is very suitable. And the main features coming to Easy EDA is like which is browser based, so no need of installation and large components of library available and seamless integration with JLC PCB for ordering the PCBs, and basic schematic capture and PCB layout tools are available in the Easy EDA. So as a beginner friendly in the mindset, currently we are proceeding with an Easy EDA and no need to install anything, because lot of PCs, lot of faculties might not having a personal PCs and even though if they have personal PCs, there will be a limitation with their RAM as well as the flash uses. So without installing anything, by using Easy EDA we can demonstrate few things and you can grab the idea. Irrespective of the software, in every software the terminology remains the same and the analogy remains the same, so you can follow and you can implement in the same way, but each software will give the more flexibility towards making it to more reliable, like KiCad, which is like better for intermediate designers, few professionals, and for the startup companies, because of it is an open source as well as a free software which supports multi-layer PCBs and open source with a strong community support. So even though if we are stuck in something, there is a support from community to use the tool, how to use the tool or how to use the supporting additionals in the same tool. And it doesn't require any licenses also. Coming to the Altium designer, which is main game player in the market for the Altium special, for the PCB design at least. It is best for high-end industrial PCB design, as well as features are advanced routing, signal integrity analysis, and lot of simulations by using AI is available in the Altium designers, and supports complex multi-layer PCBs and expensive but widely used in the industries. It is expensive because of it is licensed based in system, so it is little bit expensive compared to other models. But lot of faculties or lot of students can get the same free license from Altium for 1 year if they have the college based mail IDs. You can collaborate with Altium guys and you can get in free licenses also. Okay, for your information. And in similar way, there are a lot of other options including like RCAD, Eagle, Proteus, and Deep Trace. Each caters to different design needs. But right now in the market, the main game player or the main software in the industry is like Altium or KiCad. For beginners friendly, Easy EDA is a very better option to go ahead. If we see the software or if we go to the steps how to install or how to use an Easy EDA, today I will show from very beginning level to end level. No need to worry. In further going days, we will explain each everything step by step and we can see the stuff. No need to worry on. First, I will explain this in the PPT and then I will demonstrate the same in my PC and how to log in and how to do the stuff. And further going ahead and each step, we will be seeing everything. If we see the Easy EDA, it is like simply you can open any browser and click easyeda.com. Initially, you will see a front web page like how as it is captured, and Click on the register button and give all the details of yourself like username and password, or you can directly log in by using your mail ID also. Now, easy EDF platform send an email activation link. You have to give permissions and you need to proceed accordingly. And click on the link, proceed with the login buttons. Now proceed with the standard edition option instead of pro edition, because lot of PCs requires an higher RAM for the pro edition. But if your PCs are having more than 4 GB of RAM, pro edition is the better option than the standard edition. If your device is having and your internet connectivity is limited, you can go with the standard edition also. But if you go with pro edition, you will be having a lot of features with the AI advanced base also. It's up to your wish to proceed how you can want it to. And after successful login, it shows the following interface, how it looks like. It is a screenshot taken from the standard, but in pro also looks like same, but no need to worry on that. And basically, after logging into the page, the main intention of ours to create a PCB. So to create a PCB, these are the basic steps. Like, we need to create a project. Under that project, we will be giving the defined path, title to that project, and description to that project. And after that, by clicking the save, it will create a PCB project which is having two sessions or two files within the same project. One is schematic, another one is layout. Schematic is nothing but, as we discussed, it is an electrical connectivity, okay, which gives the component connectivity and every stuff. For an example use case, we will select a particular component from the library and we will place it on the PCB. By placing it all of them and by connecting everything, it looks like this. So by this, the schematic will be completed. We will be giving all the details like the title of the schematic, revision, company name, date, and so and so. As per your wish and convenient, you can change it. And this will be helpful when we are generating a Gerber and when we are giving these files to the fabricator. After that, just to convert the schematic into the PCB, after going into the design, convert the schematic to PCB, it will be asking related the what is the size and what is the shape it requires for the PCB. We'll be selecting everything accordingly and we will place everything strategically and we will route the PCB. No need to worry. Once again, I'm saying we will explaining what to do and how to do. Just to have a glance of idea, we are overseeing or explaining every stuff. So you can able to connect the dots when we are discussing. That is the reason we are explaining everything very quickly today. And after that, simply by clicking save and by seeing it in the 3D, you can see your own PCB as a first prototype of your PCB. Okay. This is how the PCBs will be done. But ideally, a lot of people will have a doubt like what is meant by single layer, double layer, and multi-layer with respect to the PCB designs. Okay. Single layer is nothing but a layer is nothing but kind of a side of the PCB. Single layer PCB means one conductive layer over an insulation substrate. Okay, it is like having only one single side of an connectivity connections only. Advantage is like low cost, easy to manufacture, ideal for simple circuits like LED drivers, power banks, applications like calculator, radio, or circuit sensors. But in the single layer PCB, always the routing will be only in the one side. Always a simple thumb benchmark or a thumb rule is like number of layers is equal to number of track layers. The same thing. Okay. While coming to the double layer, if you see on the left side, it is having a substrate which is an insulated material. On top of that, there is a copper layer, and below one more copper layer. It is having double layers, one layer on below and one layer on top. On top of that, we are having silk screen. Silk screen is nothing but a nomenclature layer. We will be explaining in detail regarding those layers also. Okay. Here we are having two copper layers. That is the reason we will call it as a double layer PCB. And copper layers on both the sides, allowing more compact design. So within the same form factor of the PCB, we can use the double sides of the PCB to route or to have more number of tracks within the same size, which helps in the reduce the PCB size, like increasing the routing space, and supports for the higher component density within the same size, and cost effective compared to multi-layer PCB, but it is little bit costlier than the single layer PCB. Based on our use case, we will be selecting for the single layer or double layer or even the multi-layer. The major applications like industrial control systems, power monitoring devices, all of these will come under the double layer PCBs. Okay. And in these double layer PCBs, ideally we will be having YSS and lot of other things also. If you see what is meant by multi-layer, like in similar way, how we keep a two layer, it is a sandwich of multiple double layer PCBs, where it is having multiple substrates or insulation layers in between, and there will be multiple copper layers which will be connected via YSS. YS is nothing but a connection from one layer to another layer. There will be multiple layers, and multiple layers will also be connected from one to one by using internal YSS also. Okay. The major reason in the multi-layer, there might be 4, 6, 8, 16, whatever it may be, more than two layers, we will call them as a multi-layer PCB. The major advantage is like which supports high speed and high density circuits and reduces the EMI by designing very properly and by supporting having a ground layers on top layer and bottom layer, and ideal for complex designs with power and ground planes. Applications major are regularly our smartphones, aerospace systems, and high-speed processors like our motherboards, CPUs, and every stuff. And the major PCB standards which are running in the market, like the PCB must meet industry standards for safety, reliability, and performance. Some key standard includes IPC standards, ROHS, ISO standards, and UL certifications. Under IPC standards, which are international standards for PCB design and manufacturing, like IPC 2221, generic standard for PCB design. IPC 600 defines PCB fabrication and inspection criteria. IPC 6012 specifics quality standard for rigid PCBs. These are the standards will define how to do the PCB design in real-time industries. Okay. If you want to Google it, you can Google it and you can find, you can identify the standards and you can have a look on those standards. Okay. ROHS is restriction of hazardous substances inside the PCB, ensures lead-free and environment-safe PCBs, and restricts the hazardous material like lead, mercury, and cadmium in the PCBs. Because as per the government laws, you should also agree or do the PCBs with ROHS compliances. In ISO 9001, which gives the quality management system, ensures standardized PCB production and quality control, certifies the manufacturer for consistency product control or product quality, sorry. UL certification is like underwrite laboratories, ensures fire and safety compliance, required for automation, medical and aerospace PCBs. These are the certifications need to be, or procedures need to be taken as a minimum thing. On top of this, there are a lot of other criteria like CE certification, EMI certification, EMC certification. Based on the need and requirement, we will be doing those certifications based on the applications. It is always case to case dependent. And while seeing the AI integration capabilities in EDA softwares, like current state of AI in EDA software tools. EDA is nothing but all layout softwares, not only easy EDA. If you consider any layout software tools, majorly coming to easy EDA or traditional EDA tools, mostly rule-based automation like routing, DRC, and placement remains manual and constraints driven. Like we will be saying, giving all the rules as a Python script or a command based or a prompt based. So everything will be done automatically by using an automated system. In Altium also, AI assisted place an intelligent DRC using data driven hierarchies. And there are a lot of plugins available in the Altium, which are kind of an paid versions. By using them, there are a lot of simulations can be run, like thermal simulation, not only circuit simulation, it is thermal simulation, EMI simulation, stress simulation. Such kind of simulations can also be done by using Altium AI extended tools. And KiCad, like for community plugins, adding ML based routing and footprint recommendations. There will be multiple kind of components, and it will be recommended for easy footprint recommended or easy to create the footprints very not manually by using AI. And cloud EDA and AI co-pilots are ready-made like ML for pattern recognition, schematic generation, and automated design validation based on our prompts and requirements. These are the kind of current AI development state in the EDA software tools. And coming to AI integration opportunities, and there are few more gaps also. Like easy EDA, coming to AI integration potential, easy EDA currently has no native AI engine directly inside it, but its strong API and scripting support make it highly extensible. I mean to say there is no direct uh, kind of an chatbot or something directly plugged inside the module, but it have an script kind of system where we need to generate the script, and by writing the script inside that, it will do automate or it will provide everything for us. Its cloud-based architecture enables seamless integration of external AI services via REST APIs. And the structured component library allow AI-driven part selection and alternate component recommendations, which is having an because of versatile support of multiple libraries. And built-in JLC PCB manufacturer integration provides real data for AI-based cost and availability optimization. So, as we have seen yesterday or discussed yesterday, the major headache is component selection, availability, and its cost. So, when we are dealing with the easy EDA with the integration of JLC PCB, it will be directly looking into the real cost of the component and availability of the component. Based on that, if we give the prompt like, no, I am looking for so and so, yes, it will auto select the component and it will give few recommendations for us. And the open platform design supports third-party AI tools for design automation and intelligent error detection. When we are dealing with easy a standard method and a traditional method, after that we will be seeing with using AI also, then we will be discussing regarding them in detail. And with coming to the remaining tools like for easy EDA, for Candace, for CMS, lot of other tools are also available, but we are not prominently using them. Lot of them are private tools which were used by the companies, not in open source softwares, where Altium is kind of a tool which widely used. In Altium includes AI-driven interfaces, routing automation, trace optimization algorithms in such a way. The same way in for the different softwares also. And how to better AI, integrating AI with easy EDA workflow. As we discussed, develop Python scripts using easy EDA API to connect with GPT models for design assistance from by using them, and implementing AI powered BOM optimization by analyzing the component availability, cost, and performance trade-offs, creating automated design review workflows where AI checks schematic against best practices and standards. Because sometimes when we are dealing with a schematic or designing with a PCB, we might not aware of all the standards. But if we give the proper prompt like to verify all these things, it will be looking in detail and it will be giving so and so errors or so and so corrections that what need to be taken care. And integrate AI image recognition to convert the hand drawing sketches into easy EDA schematic blocks. Currently, it is in development phase where a lot of designers or AI developers are looking into to make the schematic flow or to convert the PCB just by drawing it on the paper and converting it to the PCB by giving a simple prompt. It is work in progress, not yet implemented properly, but there are few trials are running in the market too. And build AI copilot that suggests component value impedance matching and decoupling strategies in real time. Like how when a lot of uh, applications are in the software. So right now we are seeing an AI is kind of a chart, but when we are writing a code or when we are developing something, it is instinctively giving some suggestions. In similar way, in layout also, they are building an AI copilot In few softwares, they have released as in beta version, but that is also work in progress. And future roadmap of AI enhanced easier design process might be, it looks like, in phase one, conventional AI integration, phase two, AI based schematic generation, phase three, intelligence PCB layout optimization, AI driven design validation center, and end to end AI design assistance. So in each and every phase, the AI will help us to do our own work by using AI and different models, but we should ensure and we should consider each and everything and validate each and every phase, and we can proceed accordingly. This is how the AI is enhancing the PCB design work. Thank you for today's session. If today's kind of happened quickly, and if you guys are having any doubt, we will be discussing regarding them. And there is a question in chat box. How to fix the layers? Ma'am, based on the PCB size, if let us say if there is a number of components where we have placed optimizedly, but still if you want to make the trace connections, if the PCB size is unlimited, so you can place it widely and you can connect in a single layer. But let us say if there is a complex PCB where you need to connect the jumpers or you need to make the traces more than a single layer, then you have to go to the double layer. In some of the cases, the PCB size is the most constraints as well as the thermal requirements are the more constraints. Based on that, we will be selecting either double layer or multi-layer. When we are dealing with a real-time example, then you will be getting a very clear idea on that.
So, excuse me, sir, I have one doubt.
Yes, sir, please.
Related to the PCB design, which tool is good for that, sir? Yeah,
Currently,
Altera.
currently we will be seeing an easy EDA software, sir, because Altium might not be available for all the faculties. So
Okay.
the same thing can also be implemented in the Altium. So for lot of faculties, if you have a college-based mail IDs,
Okay.
you will get free
Okay.
license for 6 months or 1 year. I can't able to recall exactly. You can
Okay.
connect with an Altium info mail ID. Once I will discuss with our team and I will try to help to give the mail
Okay.
ID of Altium also. So you will get a
Okay.
free license, so you can test on that also, no problems.
Okay. So, which one is better, sir, for your experience? So,
Hmm.
Altera is good or else ECAD is good?
So as an initial phase, Altium will be so better and it will be give lot of insights to understand. If you
Okay.
understand the concepts very properly in easy EDA, you can jump into KiCad or Altium, sir. I think some internet connectivity issue from your side. I hope you doubt got clarified, sir. We'll be looking into some other more doubts. Uh, Sir, I have one doubt. Please, ma'am,
Yes, sir.
Samira, ma'am.
Regarding, as I was asking, like fixing the layers,
Yes,
will
ma'am.
the tool do the optimization and tell
Yes,
that,
sir. Thank you, sir.
okay, as it is AI driven, will it tell like two layers will be better or three layers will be better, depending on the form factor, like how much is the size of the PCB?
Mhm.
Will the tool do the optimization and tell that, okay, this many layers are enough, or how
Yeah.
is it?
Yes, yes, ma'am. As in traditional way, previously engineers use it to think in their mind and do the calculation, and they
Yes,
use
sir.
it to select. But
Yes,
now
sir.
with an technology, with an enhancement in AI, but with respect to PCB, even though there are a lot of tools or chat GPT kind of tools are available, but lot of works are in progress. In few softwares, it is in Altium especially, it is giving suggestions, but Easy EDA is not completely integrated with AI, but
Okay.
in kind of few softwares, they are giving those suggestions too.
Okay. Thank you, sir. Thank you.
Which software you are going to demo? Easy EDA. And will the tool do optimization, sir? Yes, the tools will do optimizations with respect to layout, with respect to positioning, everything. But initially, we will be addressing everything in a traditional way so you can understand the process very betterly. Always use chart, any agent, chart agents or art AI agents as an extended hands, but not as an actual hands. Sir, even when we are use multi-layer PCB, the placement of components will be restricted to top layer only. No. Sir, if we use multi-layer PCBs also, we can keep the components on both the sides of the PCBs. Even though let us say of a double layer, we can keep the components on top layer as well as in bottom layer. And there are hybrid design models also, where we will be placing few critical components in the middle of the layer, but it was very rare case. But ideally, lot of PCBs will place the components on top layer and bottom layer on. Good session, sir. Thank you. What compliances are to be considered for double side PCBs? Compliances means based on the need only, sir, as initial phase. The compliances are the testings based on the industry needs that need to be taken care. So, I have one doubt, sir. In PCB layer, 8 layer is the max, but how about safety and security issues? Uh, this session is only for faculty or students also. Mainly we are addressing for the faculties, ma'am, as per this is an FDP program. But even if you want to have the same kind of session for the embedded in your college also, where our team will collaborate with you if you want, and we can conduct the workshop for the students in detail, because for the faculty even we can explain in the fast forward pace, because you can grasp the few things, because you might have idea on few things. But for students we have to explain in detail for all of these stuffs. 1 hour session is kind of, they cannot understand the dynamics or the more tricks of the layout design. That is the reason majorly we are concentrated on the faculties only in this session. Mr. Stravani Reddy, Reddy garu, in PCB layer, one thing to be noted, 8 layer is not only the maximum thing. We can go until 32, 32 or 64 layers also. But what, how about safety and security issues? You mean to ask with respect to what kind of safety and security, sir? You can turn on your mic and also speak, no
Sir,
problem.
about that is connections, regarding connections and components, sir.
Okay. The connections and components is like, ideally we will place the components on the top layer or in the bottom layer. The maximum number of layers increases means the routing complexity will be increases very prominently. So we should keep that in mind, as well as the debugging of the PCB will be so problematic when it is going to be having more number of layers. But in few considerations or in few cases like our mobile phones, our motherboards, ideally at minimum layers there are 8 layers, and they will go until 16 layers also, sir. With respect to safety and security, no need to worry. But with respect to design constraints, it is a big headache, as well as debugging is next to impossible for that. And few faculties asked for the immediately sharing of PPTs after the session completes. Our team will share it shortly in the groups, I think so. And if you have any queries or if you have any relevant information needed, you can always connect to Mr. Surya, or you can drop a mail to info at SSIT, where the previously.
I'll drop the mail. I'll drop the mail.
If you guys are having any doubts, we can discuss regarding that, or there is some announcement to be taken from giving from SSIT.
Can I move forward, Mr. Shankar?
Yes, I think so.
Yeah. So, dear faculty, recording sessions will be shared through mail. We have already sending everyday reminder and recording session mail to your registered mail ID. Please check once. And coming to PPTs, by tomorrow morning early hours, we are going to share the entire session PPTs day by day through in a drive folder through mail. Please check your mails. And every day we are going to give you a reminder through WhatsApp also. Please check it. I think all people got that message today. I think so. Yes. And coming to feedback link, every day we are not going to share the feedback. Every 3 days we are going to share the feedback form. We are going to share the feedback from tomorrow. Don't worry. And attendance is auto tracked, no issues. And we have a small announcement. So as a mark the significance of our 4th anniversary, which we are going to celebrate in the month of February. Every year we are conducting FTPs, as well as we are conducting national level scholarship exam for all engineering students, engineering 2nd year, 3rd year and 4th year students in the domains of IoT, embedded systems, VLSI and software. So soon, by this end of this week, we are going to launch our scholarship exam 2026. I request you you guys, like I request every faculty to share the information with your respected students so that they can get the chance for getting a scholarship and getting into our company as an interns. These are sincere requests to please success the scholarship 2026. Is it applicable for faculty? Scholarship, ma'am? Scholarship exam?
Yes, sir. Yes, sir.
Actually, scholarship exam is not conducting for faculty. We are conducting for only students here. UG and PG students especially. For ECE, EEE allied branches in the domains of industrial IoT, embedded systems and VLSI. And we are giving 2 lakhs till 2 lakhs rupees worth of prize money to the students all over India. Last year, nearly 2,400 people has attended for the exam. So this year we are planning for a big one because this is our 4th anniversary which we are going to celebrate on February 23rd. So by this weekend we are going to launch our scholarship exam anyway. Yeah. So that's it, guys. That's it for today's session. Thank you. Bye bye. Have a nice day.